All right, good morning. Today we're going to get started on section 5.2 with a new definition. And what we're going to define today are what are called congruent shapes. And the definition for shapes that are congruent definition is shapes with both equal sides and equal angles. Shapes with both equal sides and equal angles. A little bit of an adjustment from some of the similar shapes that we talked about back in chapter 4. Here we're talking about congruent shapes, so we're going to have triangles and quadrilaterals and pentagons and so on. But now they're not going to be similar to each other, they'll be congruent to each other. We have some notation that goes along with congruent shapes, and the symbol that we use for congruent is an equal sign with a wavy line on the top. That wavy line is called a tilde, if anybody's interested. That single wavy line is called a tilde. I'm pretty sure I spelled that correctly. But when we put that together with an equal sign, we create the symbol for congruent. And one of the more important ideas that we're going to use with congruent shapes is this idea of corresponding parts. And what we mean by that is the sides or angles in the two shapes which are, that's a terrible R, which are equal. And we're going to do several problems in a row where we're going to practice identifying corresponding parts. Which sides in this triangle are equal to which sides in that triangle? Which angles in this triangle equal which angles in that triangle, and so on. So we've got to practice so we get a really good understanding of what are called corresponding parts. Okay, so I'm going to run you through several examples practicing with that idea, the corresponding parts idea. So if I were to give you a triangle like the following, A, B, C, and a second triangle, D, E, F, and I was to give you some information about the triangles, I were to give you some information about the triangles, then you could see that all three sides of the top triangle equal all three sides of the bottom triangle. All three angles in the top triangle equal all three angles in the bottom triangle. So since all of the sides and all of the angles are equal, we would say that the two triangles are congruent, and we would write that by identifying the letters triangle ABC. We'd use our symbol for congruent, and then before I give you the second part, the second triangle, you might just think, well, I'll just do it alphabetically, but we do it in a special way, and let me show you how that works. We're going to write the vertices for the second triangle in a special way by considering which angles are going to be corresponding to which, and then which sides are corresponding to which. Again, corresponding means two pieces or two parts that are equal in the two different shapes. So I think you can tell from the tick marks that if I start you guys off with angle A, angle B, angle C, the three angles from the top triangle, you can clearly see which angles in the bottom triangle they're equal to. A has one tick mark, D has one tick mark, so those two are equal and therefore called corresponding. B has two tick marks, F has two tick marks, so we call those corresponding. And finally, angle C has 3 tick marks, angle E has 3 tick marks, so we call those corresponding, right? And therefore, because I ordered in the statement, I said A, B, C. Those then have to correspond to the same equal angles. And since A was first, D has to be first. Since B was second, F has to be second. Since C was third, E has to be third. They have to be corresponding. So the first has to equal the first, second has to equal the second, third has to equal the third. Also, of course, you could label which sides are equal. So if I gave you the 3 sides for the top triangle, you can clearly see by the tick marks which sides are going to be corresponding. They're going to be the sides that are equal. AB has 1 tick mark, DF has 1 tick mark, so those are equal and they're called corresponding. BC has 2 tick marks, EF has 2 tick marks, so those are called corresponding. AC has 3 tick marks, DE has 3 tick marks, so they're both equal and called corresponding. Okay? All right, so that's a nice simple example with a triangle. Let me do a similar problem with a quadrilateral. All right, so I'm going to give you 2 quadrilaterals. All right, and I'm going to call this one H, I, J, K. And then I'm going to draw a second here. And call this one L, M, N, O. And instead of using tick marks to show you which sides are equal and which angles are equal, instead, what I'm going to give to you, tell to you, is that quadrilateral I, J, K, H is going to be congruent to quadrilateral, M, N, O, L. Right? And then what I'll ask you for again is which angles in one quadrilateral equal which angle in the other, so which ones are corresponding, and I'm going to ask you which sides in one are equal to which sides of the other. So I'll start you off with the angles in the first, so I, J, K, H. So which ones are those going to be equal to in the other quadrilateral? Well, again, it's all about how we write the statement. Since I is the first letter and M is the first letter, I and M must be equal to each other. Since J is the second, N is the second, J and N have to be equal. K is the third, O is the third, K and O must be equal to each other. H is the last, L is the last, so those have to be equal to each other. Right? So you can tell which ones are corresponding by the congruent statement. Now, if it's helpful, of course, you can feel free to go up and identify I and M are equal, J and N are equal, K and O are equal, H and L are equal. Feel free to put that into your diagram if it's ever helpful to keep track of what's equal to what. Then the sides, I'm just kind of looping around here. In fact, I'm going to purposely do them out of order. So I'm just trying to randomly grab these. So HK, IJ, JK, IH. So I'm just trying to randomly grab the sides from one of the quadrilaterals. And now I'd like you to pair those up with the corresponding sides from the other. And 2 perfectly fine ways to get this done. Number 1, you can, as an example with HK, let me just choose a highlighter tool so you know where I'm at. HK is right here. And please notice that's the side in between the angles with 3 and 4 tick marks. So you can go to the side between the angles with 3 and 4 tick marks, and those must be corresponding. So HK and LO would be corresponding to each other. Just do another one with that same highlighter idea. My next side I picked was IJ. IJ is right here, and it's in between the angles with 1 and 2 tick marks. So if I pair that up, between 1 and 2 tick marks in the other picture is MN. Okay, and that works perfectly fine. Or, notice on the third one, JK, which one is that going to be corresponding to? Well, please notice J and K are the middle 2 letters in our congruent statement. What 2 letters are in the middle of our second statement? N and O. So therefore, they have to be corresponding to each other. And of course, I'll finish this off. IH, first and last letter over here, M and L. So we want you to be able to identify corresponding angles, corresponding sides in congruent shapes, Okay? And in fact, you can actually do that without the pictures at all. You can identify which angles, which sides are corresponding. As an example, if I were to give you triangle PQR is congruent to triangle STU, I don't even need a picture to identify which angles are going to be corresponding, therefore equal, and which sides are corresponding and therefore equal. I don't even need the picture. I can do that from the statement. I know which angles are equal to which. First equals first, so angle P and angle S have to be equal. Second equals second, so angle Q and angle T have to be equal. And third has to be equal to third, so angle R and angle U have to be equal to each other. So you can tell which angles are equal to which. First equals first, second equals second, third equals third, and so on. And then you can do the same thing with sides. I could list the sides from one of the triangles, PQ, QR, PR, and then just pick off the corresponding letters. Which side is going to correspond to PQ? Well, P and Q are the first 2 letters. So the first 2 letters in the other triangle are ST. So therefore they have to be equal and corresponding. QR is the second and third letter. The second and third letter in the second triangle is TU. Therefore they have to be equal and corresponding. PR, first and third. First and third in the other triangle is SU. Therefore have to be corresponding and equal. Okay? So we're going to ask you to practice with that because it's that idea of what's corresponding that becomes really important and really useful to us as we move along in the remainder of this chapter and into the next 2, not so much chapter 6, but chapter 7 for sure, becomes a big deal in that one as well. So we'll be using this idea of corresponding an awful lot. We'll be using that an awful lot. Okay? So next up, let's set up a couple of numerical problems. You know I like these, and you'll most likely see them on your test. So give me a second, and I'm going to draw you guys a picture of 2 triangles. And I'm going to tell you these 2 sides are parallel to each other. Those 2 sides are parallel to each other. And then I'm going to give you some information about this one. This side is 7, this side is 6, and this side is 10 long. Right? Then I'm going to tell you this angle is 55 degrees. This angle is 85 degrees. And this angle is 40 degrees. So I'm going to tell you all 3 angles there. And then I'm going to label some of the sides here, or I'm sorry, the vertices is what I meant to say. So A, B, point in the middle is C, and then D and E. Okay? So with the information shown, and one last bit of information, I'm going to give you one last bit of info. I'm going to tell you that triangle ABC is going to be congruent to triangle DEC. So DEC, they're going to be congruent. And then what I'm going to ask you for are some missing pieces, like What's the measure of angle A? What's the measure of angle B? What's the length of CE? What's the measure or length of DE? What's the length of CD? And I'm going to include one red number so that I don't have to use a bunch of letters. I'm also going to ask you for the measure of angle 1. All right, so is there enough information on your picture to determine all of these missing parts? And the answer is sure. Okay, as an example, since I show you in the picture that angle E is 40 degrees, E is the middle angle in our statement, that therefore must be equal to the middle angle in the other statement, which is B. So B must then be 40 degrees. D, as an example, is 85 degrees, and since D is listed first, that therefore has to be equal to A, and so therefore A has to therefore has to be 85 degrees. Right, and I forgot to attach that one, so I will there. Angle 1 you could get to in a couple of different ways. You could use the idea of corresponding, or you could just use vertical angles, but angle 1 is going to be 55 degrees. And then just going through the sides in a similar way, since I tell you that AB is 7 units long, and AB is the first two letters, the first two letters in the other triangle, DE, must also be 7 units long. Since in the triangle to the left I tell you that BC is 10 units long, B and C are the second and third letter. The second and third letter in the other triangle, E and C, has to be 10 units long. And then just finishing off the thought, AC has to be 6 long. Please notice A and C are the first and third letters. So the side with the first and third letters in the other triangle, DC, has to be exactly the same, 6 units long. Right, so you can find missing pieces if you know that the triangles are congruent. If you know that triangles are congruent. Okay? Excuse me. All right, so gonna do one more thing, and then we're going to stop the video and give you some time to work. We're going to do one theorem before we call it a day here. And this theorem is called the third angles theorem. And first I'll write it out, and then you and I will walk through the proof. Okay? So here's how it goes. The third angle theorem says if two angles of one triangle are equal to two angles of a second triangle, then the third angles must be equal. That's messy. Let me do. Must be equal. Right? If two angles of one triangle are equal to two angles of a second triangle, then the third angles must be equal. So if I were to give you two triangles, calling this one ABC, calling this one DEF, and if I told you that, come on, darn it. If I told you that angle A and angle D are equal, if I told you angle B and angle E are equal, since we have two angles of one triangle equaling two angles of a second triangle, then what you can deduce, what you can figure out, is that the third angle from one triangle must be equal to the third angle for the other triangle. So in our case, angle C and angle F must be equal to each other. Okay? All right, so there's the theorem, and now I'm going to do the proof with you. So we're going to walk through a 2-column proof. So I'm going to start with the diagram. And I'm just going to change letters just so you don't think there's anything special. You can use any letters you want, of course. So I'm just going to call this one H, I, J. And just for something different, I'll just call this one X, Y, Z. And then what we're going to give you is that two angles in each triangle are equal. So I'm going to tell you angle H equals angle X, and angle I equals angle Y. And then what you're going to help me prove is that the third angles, J and Z, are equal to each other. Okay? So like always, feel free to pause the video if you need to just do some writing before we get going on the steps. Feel free to pause. But I'm just going to go ahead and get started here. So we always begin with the information we're told. So we're told angle H and angle X are equal. That's given to us. If it helps, feel free to put some tick marks over here. H and X are equal. Okay? Then, second piece of given information is that I and Y are equal. That's given to us. Again, feel free to put some tick marks in here. So this one and this one are equal. Okay, now what do we do? Now what we could do is we could say that the sum of all three angles in the first triangle, H plus I plus J, would add up to 180 degrees. Why do we know that's true? Why is H plus I plus J equal to 180 degrees? Because of the triangle sum theorem that we just proved in section 1. And if that's true for the triangle to the left, it's also it's also true for the triangle to the right. So we can say then that angle X plus angle Y plus angle Z has to equal 180 degrees for exactly the same reason, the triangle sum theorem. And what we've ended up with then are two things that are each equal to the same thing. We have H plus I plus J equaling 180 degrees. We have X plus Y plus Z equaling 180 degrees. So if we have two things that are each equal to the same thing, they must be equal to each other. So I can then say that H plus I plus J is going to be equal to X plus Y plus Z. And I'm going to choose, even though substitution is perfectly fine, I'm going to choose transitive property for the reason. And then what I'm going to do is make two substitutions. I'm going to make two substitutions. I'm going to replace angle H with what it's equal to. I'm going to replace angle I with what it's equal to. And I'm going to leave everything else alone. All right, and when I replace something, let me choose a highlighter so you see exactly what I did. I replaced H with what it was equal to. I replaced I with what it was equal to. So when I replace something with what it's equal to, that's called a substitution. All right, and by making those substitutions, I now have the same letters on both sides. I have an angle X on both sides, so I could subtract it away. I have an angle Y on both sides, so I could subtract it away. So obviously my last reason is going to be the subtraction property. But let me just finish off then. So on the left-hand side, the X minus X, Y minus Y cancel. On the right-hand side, X minus X, Y minus Y cancel. So what we're left with is angle J and angle Z are equal. And of course, you can see that that is exactly what we were trying to prove. So again, that's how you know you're done, when your last statement matches up perfectly with what you're trying to prove. Okay, so there's a proof for the third angles theorem. All right, we'll finish off the rest of section 2 when I get back on Monday. And so this one's going to be due on Tuesday, but you have a decent amount of time. So you should be able to get some of the problems from the assignment done. Okay, so we'll talk to you guys on Monday. Have a good weekend.